Let's go ahead and talk 1.1, inductive and deductive reasoning. So, in this section, we're going to go ahead and talk about these two major types of thinking. We're going to define them. We're going to do a couple of examples to really solidify what we think about them. And then we're going to identify some examples and see, is it deductive or is it inductive reasoning? So let's go ahead and start off with defining inductive reasoning. So if I look at inductive reasoning, this is the process of reaching a general conclusion by looking at specific examples. In other words, if I have some previously established data, some past examples or current examples, I can make a conclusion based off of that information. This is what we call our inductive reasoning, taking what we have and making conclusions from that. So that conclusion that we actually make from inductive reasoning, we call this a conjecture. We call this a conjecture because whenever I'm making my conclusion, I may not be sure if it's actually correct or not. So we've defined our inductive reasoning and what a conjecture is. So let's actually put this into practice and do a couple of examples. So let's start off with example one. Example one, using our inductive reasoning skills, let's predict the next number in this list. And then we're going to go ahead and briefly describe the pattern used to predict that next number. So here I have a list for part A, 3, 6, 9, 12, 15, and I want to figure out what's next. Well, looking at this, you can probably already make a guess on what we're going to see here. If I look at this list from the very beginning, I'm going from 3 to 6, 6 to 9, 9 to 12, and 12 to 15. What I'm noticing is that from 3 to 6, I'm having a jump of plus 3. But fortunately, I also see the same thing from 6 to 9, 9 to 12, 12 to 15. Each time, it looks like we were adding 3 to my total. If I was following this pattern from after 15 of adding 3, well, let's see, 15 plus 3, we get a nice 18. And actually, that's what I'm going to guess is my next number, 18. So I want to take a moment and notice that I said use inductive reasoning to predict the next number. And we're going to see what is the most probable number. Now, for all we know, there could be a pattern here that's not just as simple as plus 3, but this is the one that's making most sense for me looking at it right now. So I have my prediction, and one important thing is our second set of instructions. Briefly describe the pattern used to predict the next number. In other words, we're going to use some proper sentence structure to explain what we're having, not just writing what I have on screen plus 3. So how do I write that? Well, one way I can go ahead and write this is to get the next number, to get to the next number or value, whatever wording you want to use. I'm not going to be too fancy. I'm going to say we add 3 to the value. To the value. Just something where it's very clear and more than just me saying plus 3 each time. All right, so I have my prediction and my number. And this finishes off part A of our example. Let's do another practice one with part B. If we move on to part B, same instructions, but now I've got 1, 3, 6, 10, 15. So what's my pattern here? Well, looking at this initially, it doesn't seem to be as straightforward as the plus 3 we had earlier. To help me go ahead and figure this out, let's go ahead and see what's the difference between each of my values. So if I was going from 1 to 3, I'm saying, well, plus 2. Well, what 3 to 6? I can say, well, the difference is plus 3. 6 to 10, plus 4, 10 to 15 plus 5. And I'm going to say, are you noticing a pattern here? Well, if I were to go from 15 to the next value, you might be noticing I had plus 2, plus 3, plus 4, plus 5. If I were to go by the pattern, you can probably guess that I'm going to put plus 6 next. So if I do 15 plus 6, then that's going to give me 21. And I'm going to say that that's my prediction to get from one value to the next. Based off this pattern, you can probably guess what's happening after 21. To get to 21, I added 6. After that, I'm probably going to add 7, then add 8, and then so on and so on. So I have my prediction, but how am I going to describe this? So I'm going to give a little bit of an informal explanation to keep it a little bit simple, more or less as simple as we can, at least. What I'm going to say is to get to the next number, number, value, whatever you want to say, we are adding, and I'm going to use a little bit of a fancy word, consecutive integers. Consecutive meaning I went from plus 2, the next one being plus 3, plus 4, plus 5, plus 6, so on and so on. So I'm going to try to keep it simple, just so that we're not too focused on the exact wordings here. So I have my prediction, 21, and then a sort of explanation to describe how did I get to 21 and everything after that. So I'm done with my example 1, part B. So here I gave you a list of numbers in this particular sequence, and then we were able to observe patterns from that list. After I identified that pattern, I made my prediction, and then I try to go ahead and use my words to explain this. Now, let's go ahead and move on to example 2. If I move on to example 2, let's look at this. Consider the following procedure. Let's say I told you to pick a number, multiply that number by 8, add 6 to the product, and then divide that sum by 2. Then finishing it up with subtracting 3. So to help us with this, let's complete the procedure. Let's say I chose the numbers 1, -2, and 4. After I do this, let's use our inductive reasoning skills to make a conjecture about the relationship between where we started, the starting value, and then where we ended, our final value. So here I have a table conveniently. Let's start off with the first one, number 1. So for 1, I chose the number 1, and then I'm going to multiply that number by 8. So 1 times 8, I get, well, 8. Step 3, add 6 to the number. So 8 plus 6, we get 14. Step 4, divide by 2. We get 14 over 2, which gives me 7. And then subtract 3. 7 minus 3, we get 4. So this is me completing the process whenever I started with picking the number 1. Let's do the same thing for -2 and then 4. For -2, what's -2 times 8? We get -16. I'm going to try to fit everything in these boxes. Adding 6, we get -16 plus 6, giving me -10. Dividing by 2, we get -10 over 2, we get -5. And then -5 minus 3, we get -8. Now let's finish it up for 4, and let's see if we can get any patterns after that. So step 2, excuse me, multiplying by 8, 4 times 8, we get 32. 32 plus 6, we get 38. 38 over 2, what do we get? 30 over 2, we get 15. 8 over 2, we get 4. 15 plus 4, we get 19. And then 19 minus 3, we get 16. So I've completed this procedure for 3 separate numbers. Let's see if there's a relationship between where I started and then my final value each time. So take a moment and see, do you notice a pattern here? Let's see, 1 to 4, -2 to -8, 4 to 16. So if you've noticed, I'm noticing a pattern here. I noticed from where I started to where I finished, it appears that my first number, I can multiply it by +4 and get to my final number. That is, we can see it here. 1 times 4, we get 4. -2 times 4, we get -8. 4 times 4, we get 16. So I'm observing this data in these examples, and my conjecture, let's go ahead and write that, conjecture. Hopefully I can spell it right. I'm going to go ahead and say the final value is 4 times the original. This is going to be my conjecture. And I can probably test this out if I wanted to for more values. For example, if I plugged in 5, 6, whatever your favorite number is, even if we had fractions, I could plug in 1/2 from the start. Or at least we're predicting that it's going to be 4 times the original value will be the result of this procedure. So we have our example 2. So we've talked about our inductive reasoning, but there's a second part to this section, deductive. Let's see what's going on with deductive reasoning and how it's a little bit different. Oops, and I do actually have a little bit. I went a little bit ahead of myself here. It's actually not in y'all's notes. So, but I can still cover it. Not a problem. So a couple of quick definitions here. A statement is a true statement if it is true in all cases. And then if we can find one case for which a statement is not true, called a counterexample, then the statement is considered a false statement. So I did move this to a different section, but it looks like I forgot to update my notes. This is nice and good for us, actually, because you're going to hear me talk about these things called true statements and false statements. But we're going to hold off on this and wait until we get into later sections to really get into this idea of true and false. So long story short, you're going to see it in the future. So since we're holding back on this, let's go ahead and actually move forward. And let's go to the part that I thought was going to be next. Deductive reasoning. There we are. So what's deductive reasoning? Deductive reasoning is the process of reaching a conclusion by applying general assumptions, procedures, or principles. So what's the difference that we're seeing here? Before in inductive reasoning, we had specific examples, and then we made a conclusion. In deductive reasoning, we're applying general assumptions, procedures, or principles. So we're not working off exact things to make a conclusion. We're going off just general broad ideas and seeing if we can apply it elsewhere. So right now, it's a little bit abstract, but I'll have to ask you to hold on for me. Let's see if it makes a little bit more sense whenever we get through these examples. So let's jump into example 3. Let's use our deductive reasoning skills to show that the following procedure always produces a number that's 4 times the original. So here I have the procedure. Pick a number, multiply that number by 8, add 6 to the product, divide by 2, and then finish off by subtracting 3. You might be noticing something. This is actually the exact same process that I had in the previous example. How are we going to take this on differently? We saw that using inductive reasoning, it should be 4 times the original. Well, in this case, what we're going to do is I'm going to go ahead and be very broad with this. Suppose I pick a number. Let's actually label this step 1, pick a number. Step 2, multiply the number. Step 3, add 6. Step 4, divide. And then step 5, subtract. So instead of picking a specific number, let's be broad. Step 1, choose a number. Let's call my number n. Step 2, multiplying by 8. I get 8 times the number n. Step 3, add 6 to the product. So 8n plus 6. And then step 4, divide the whole thing by 2. And then step 5, subtract 3. So we get 8n plus 6 over 2 minus 3. So I'm looking at this and I'm like, well, this is a bit of a mess we have. But let's see what happens whenever I clean this up. So I'm going to move this all the way back up. Let's see, 8n plus 6 all over 2, and then to the side, minus 3. So I'm going to write this out just so that we can all keep track of it. We have 8n over 2 plus 6 over 2 minus 3. What's 8n divided by 2? Well, 8 divided by 2, we get 4n. 6 divided by 2, we get plus 3. And I'm going to bring down the minus 3. By now, I'm noticing some cleanup work, which is really nice. 3 minus 3, that becomes a 0 pair, becoming 0. And I'm left with 4n. So let's look at what happened. I started off with choosing a number. Through my process and cleaning it up, I can see that I have 4 times that number. So notice what I did differently here. There are some similarities, but broadly speaking, I chose an arbitrary value n, went through my process, and saw that I have 4 times the original number at the end of all of this. I didn't do any plugging in of n. I didn't choose examples. I applied this general process and was able to get an idea or a conjecture about what I'm working with. So we have example 3. The last thing I want to talk about in this section lecture is let's go ahead and look at some real world examples and let's identify if it's inductive or deductive reasoning. So example 4. Determine whether each of the following arguments is an example of inductive or deductive reasoning. So in scenario A, during the past years, a tree has produced plums every other year. Last year, the tree did not produce plums, so this year, the tree will produce plums. So let's see, how do I identify this as inductive or deductive reasoning? Remember, for inductive reasoning, I'm working off of our current data or given data. Did I have a specific example and make a conclusion based off of that? Well, in this one, I know that my tree produces fruit every other year. Last year, it didn't produce fruit, so I'm thinking this year it's going to produce some fruit for me. The key thing that we're going to be looking at is where it said in the second sentence, last year, the tree did not produce plums. So we made our conclusion. That is, I took an example, what happened last year, and based off that example, I can predict what's going to happen this year. So if you guessed inductive reasoning, you'd be correct. We looked at something that was specific and we were able to make a conclusion based off of that, giving us inductive reasoning. So we have part A. Let's see if we can do the same thing for part B. For part B, I have, let's say that all home improvements cost more than the estimate. Well, the contractor estimated that my house improvement is going to cost $35,000. Therefore, my home improvement will cost more than $35,000. So, is this inductive or is it deductive reasoning? Did I work with a specific example to make my conclusion? Key word here, did my example or general idea lead to my conclusion? Well, here, if I read the first sentence, I said all home improvements cost more than the estimate. And my conclusion is my home improvement will cost more than 35,000. So yes, I am looking at my particular scenario, but my $35,000 wasn't really the thing that led me to my conclusion fully. My conclusion came as a result of me thinking, in general, all of home improvements cost more than the estimate. So in this case, we actually have deductive reasoning. Like so. So a quick one for part B. Now let's go ahead and look at my last one for this lecture series. Let's look at part C. Part C says all Gillian Flynn novels are worth reading. The novel Gone Girl, if you've seen the movie, or read the book, both either great, is a Gillian Flynn novel. Thus, Gone Girl is worth reading. So, we gotta think, did I have a general idea and then it led me to a conclusion? Or did I have very specific data that led me to my conclusion? The confusion here is that we might be thinking, well, there is something specific here, but did it lead to my conclusion? I'm going to go ahead and make the claim that this is deductive reasoning. The reason why? Well, it says that all of these novels are worth reading. I named something based off of that. And because of this reason, I was able to make my conclusion, leading me to think that this is going to be deductive reasoning. So we've talked about a couple of examples with inductive and deductive reasoning. And this is just going to be the start of how we think about how we think, actually. All right, so I'm going to see you for the next video.